Good evening, everyone, and welcome to our 2022 network design presentation. My name is Richard Cardona. As everybody knows, we are up for our 5-year refresh, and every time at this point, we take a look at our network infrastructure. We discuss what upgrades that we're going to need to implement. We, of course, got a budget this term. I'll be happy to present that through our traditional options. I've actually done better with our budget. We've allowed ourselves $3 million for our refresh, and that's usually what we're about budgeted for our 5-year refresh. So I'm going to present to you what I've come up with as far as our traditional network needs. And I'm gonna throw a little twist in there and give us some ideas on some cutting edge technology and a direction that we may want to consider going for the next year, for the next 5 years. So real quickly, I'm going to go ahead and run through a quick presentation, show you what our network looks like at each of our 4 locations that we currently have. Each of our locations have a minimum requirement of hardware. We know that we need at least 2 switches, 2 firewalls, an intrusion protection device. We need 2 routers for redundancy. We need MPLS internet so that we can deliver the data across multiple locations geographically. That meaning that we've got 4 different locations that are not in Albuquerque or in the building in Albuquerque. We've got our Rancho Cordova location, we've got our location up in Vancouver, and we also have our location in Denver. So we know that we've got infrastructure built into all of this so that we have to have a mesh network that interconnects all of these so that we can pass the data that we need to, so that we can continue to provide the services that we do to our customers. So I'm going to go ahead and begin the presentation. I'm going to show you what our current infrastructure is looking like. We're going to look at our cost structure, and I'm going to show you how I was able to stay under the $3 million budget that we had allotted. And then we'll talk a little bit about a new technology called SASE. And then we'll take some questions at the presentation. Okay, so I'm going to go ahead and share my screen here. Okay, so network design presentation. I'm going to go ahead and go to the first slide. If we can go ahead and skip the next slide, please. Okay, so for those of you who are familiar, this is an example of the infrastructure that we have at a single location. And this infrastructure at a minimum has to be replicated at each of our locations in order for us to have redundancy, security, and the ability to transfer over our data across the country. So we're going to talk about how all of that works. I'm not going to go into too much detail here because I want you to understand just where the budget is going, because this is our core infrastructure, and these are the items that we typically replace every 5 years. So if we look at this diagram, starting from the very top at the cloud, this is the internet. So our data and just infrastructure, or sorry, services that we need that come into our building, we need the internet for just about everything. We do have some core services that are built in within each of our locations that we have locally. Should the internet go down, we would still have access to that. However, things like our network printers, our network file shares, servers that contain data or videos that we provide to our customers all exist at different points or at different locations that we have. So we've got to be able to pass that data over without any interruptions. And this is how we get it done. So kind of taking a look at this, going back from the internet, we're going to look at the line that comes over to MPLS. MPLS is a type of internet service and a routing service that allows us to basically have a tunnel, our own personal pathway through the internet that interconnects us to all of our different locations. And the reason for that is that we don't want our data just to be out on the internet where anybody can kind of pick it up. The information that we deal with is confidential, so we don't want to have any issues with our data going out as far as security. We need to keep that safe, we need to keep it secure, but we still need to be able to pass that information not only to our different locations, but out to our customers. So MPLS provides that service to us. There's VPN tunnels that go through our MPLS, and also that MPLS, by the way, stands for multi-packet layers switching, or labeled switching, excuse me. So as data goes through this MPLS, it gets labeled, it knows where it's going, and that's how we can get our data from one point to another. It's this MPLS that kind of controls that. It's our command and control. Okay, so that's how the MPLS works. That MPLS runs through routers that are connected to the internet. So you can see that the next point in this diagram runs to our routers. We have to have 2 routers at each location for redundancy. We do provide live service to our customers, so we can't afford for any downtime. So the reason why we need 2 routers in our infrastructure at each location is that one router goes down, we have failover to another router so that we can continue to do business, stop, fix that second router, and get that back up, but not have any gaps in our service. So we'll need to have both of those routers in place. The next step, as information is coming in from this internet through our MPLS and down through our routers, it's going to get inspected by our intrusion detection devices. Now, intrusion detection, basically what it does is it takes a look at the data for different things. It looks to see how much data is coming through, where it's coming from, and if it's something that we recognize, basically. So it gets checked here before it even comes to our firewall. So that information comes through our intrusion detection device. It decides whether this is still safe information. And once that's complete, the packet inspection is complete, it passes it down to our firewalls. Now, just like our firewall, our routers, our firewalls have to be redundant. We've got to be able to stay up and running, and we've got to check all of the data that comes in. So after that initial inspection through intrusion detection, it goes through our firewalls. Our firewalls then check the next label on that piece of data or the packet to see if it's allowed to come any further into our internet. So now we get a little bit of extra security here, where our firewall is now looking at our rule set to say, oh, okay, I know where this came from. I do see that we have a rule to allow this through. We can pass this through, or it can come through. If the intrusion detection system doesn't detect anything weird, it passes on to the firewall for further inspection to see if some of the finer tuning access control lists that we have built have any matches for that. And that's basically what it looks like. So it comes through, it looks at this piece of data, says, yes, that's okay to come through, and goes through to the switch. If it's not okay, it actually just drops the packet. It doesn't come through. Our firewall stops it right there. Same with the intrusion detection. If it detects any kind of anomaly, it sends a log to let us know what's going on, and we can then go back and re-inspect those logs and find out what's happening, and then we can set further access control rules at our firewalls to block some of this stuff. So it's letting us know what's going on. But the firewall, it gets here, it's not allowed, it drops, it doesn't go any further. If it does, it comes through our switch, and from there, from that switch, we may have different devices connected to this. Maybe a server, maybe your PC, maybe a printer, whatever it may be. That information then goes down to the switch. The switch takes a look at where it's going and then delivers that data to its endpoint. Okay, so after looking at all of this, we see that this is what we need on just for our basic core network. And again, we do need this redundancy. The switch behaves in the same way as the firewall and the router. If one of them goes down, it fails over to serve our population so that we can have continuous service down. Okay, so the next slide that we're going to kind of take a look at is the cost. Now, We mentioned having a $3 million budget for this. I'm going to go ahead and go over the next screen and just review the cost for the refresh on our traditional network. So you would be happy to know that just kind of looking at what is out there now, and even with the increased cost of newer technology, we've gone out and we've kind of taken a look at this. We've got two different vendors that provide us this information, and as you know, we already get about a 50% discount on this hardware. So the cost that we're actually seeing here, the average cost per 5 years, this is our reduced cost. The cost per router is actually a little bit more for each. So this is where our vendors were able to come back with, and you can see that we're under budget. Now, I've got this set up as $32,000 because this is actually, if you divide this by 5, this will give you the cost per 1 year, but it's giving us the average cost per 5 years. So we refresh every 5 years. So for the routers, $32,000 for 4 locations, and we need 2 routers at each location. So I've got 8 as the quantity needed, and we see that's going to cost us $256,000 to refresh our routers this refresh route. Okay, and as we go down the list, we see that for each of the items that we mapped out in our diagram earlier. So switches, again, we need redundancy, so we have 8, $180,000. Firewalls, 8 as well, $272,000. The intrusion prevention device, we need 4 because we only have 1 at each location, $48,000 for the next 5 years. And the MPLS internet. So this is just a service that we pay for the MPLS switching and labeling, $48,000 for the next 5 years. And we need 4 subscriptions to that service, which is at $192,000. And of course, we put this in for the budget of the networking team because at each location currently, we need a network admin on premise to make sure that we get any failures taken over. We have somebody on-prem to config any of our devices if they go down. And as you know, we currently have 1 at each of our locations. And I put an average of $80,000 in here. We know that the salaries fluctuate, but the average between each of them is about $80,000. So we look at that, 5 network administrators for each location for 5 years, $400,000 for that 5 years. We need 4 of them, and so our total cost there is $1,600,000 for salaries to maintain this infrastructure. Okay, so great, right? This is what we would be looking at to refresh a traditional network, and you can see we're under budget. We can always work with our vendors when it comes crunch time. We could probably get that down, maybe save another $100,000 or so. So this is what I would propose for a traditional network. Now, what I'm excited to present to you today is something called SASE. Now, in 2019, there was a new technology introduced into networking called SASE. Now, it builds off of an SD-WAN infrastructure. SD-WAN is similar to MPLS. And if you remember what MPLS does is it allows us to operate between different locations like we're all in the same building. We can transfer this information, we can move it around, get it to where we need to go. SD-WAN, what that did was it moved that MPLS infrastructure completely to the cloud, which means that you didn't need routers to move that information around. It moved the routing up into a cloud-based service, and the routers were able to be eliminated. What ended up happening was the information would go straight out to the internet through our firewall, and then the SD-WAN system would kick in. It was a cloud-based system. SD-WAN was great because it allowed us to get rid of the routers, but we still had infrastructure downstream that we needed to inspect our data, the intrusion detection devices, the firewalls. Those are expensive devices, and we can't get rid of those with SD-WAN, but was able to cut us some savings because all of that information went up to the cloud. Well, in 2019, Gartner introduced a technology called SASE. So I'm going to go ahead and switch over to this next slide. Okay, so looking at this compared to what we just saw, you can see that a SASE network has a much smaller footprint. So as we're kind of looking at this, you're like, well, okay, so 3 things. We saw the last slide. We don't have any firewalls. We don't have any intrusion detection devices. We don't have any routers. All of that infrastructure has been cut out. And where has it gone? Well, believe it or not, this is all we need to run our entire network based on this new technology. Again, it's cutting edge, 2019, but it's tried and true. And there are a few companies out there that do this very well. Now, I've been looking for a SASE provider that has a small footprint where we can get less devices in our network and does everything that we need to do. That's fully cloud native, it's global, and it converges all of these networks in the cloud. So what we have come up with is a company named Cardona. They've given us some wonderful presentations, and they've showed us how we can do all of this in a cloud environment and get rid of all of that infrastructure. So before you say anything, and I know that everybody is used to having these traditional network devices, when we're going to go through here, I'm going to show you how everything kind of works, and I'm going to give you some advantages up front. Okay, each one of those devices that we saw in the graphic before needs specialized configuration. It needs somebody there on-prem to put their hands on it if something goes wrong. We need to go in there, we need to do cabling whenever something changes. All of those changes have to happen on physical devices. They're also stored in cabinets. They pull a lot of energy. There's a lot of things going on. So there's a lot happening in those infrastructures. That's why we have to have all of those salaries, which you can see eats up a ton of our budget to make those networks happen. What SASE does is it converges all of our sites and all of our networks and all of our security needs into a single infrastructure that's cloud-based and allows us to manage all locations through a single pane of glass. What that means is that we can do that from one machine. One machine, one administrator to look over the entire network. So let's take a quick look at how that works. Okay, so remember all that stuff that we saw? Now, I don't want to go too far into this, but I want to explain how a fully converged, globally located, cloud native infrastructure can do everything that we need to do, except move the infrastructure into the cloud. It does a couple of things for us. Makes us more agile. If we have to move for whatever reason, we don't have to take that equipment with us. It's cloud-based. We take those 3 pieces of hardware that I showed you in the previous slide, we move on, and we log right into our cloud-native infrastructure. It's scalable. We can literally install a client, a small piece of software on a piece of machinery that'll connect us to this network without any hardware other than our PC. Why is that important to us? In the environment that we're in now in a pandemic, where we've proved that, well, not proved, but we've seen that we've got to be agile. We've got to have a disaster recovery plan. And if we're going to stay in business, we need employees. Our employees can't come to the building because there's a pandemic going on. How are we going to serve our customers? Well, having a fully converged cloud native security and network infrastructure is going to do that for us, because what we see in this graphic in the lower right hand corner, this Cardona SDP. So you can see the little person here with the laptop. What this means is that this person has the Cato client installed. With that Cato client installed, they're able to log in and they can get direct access to this cloud native infrastructure. So again, they don't need to be at work, they can work from home. You can already see the advantages of this in our current situation. But I'm getting too far ahead of myself. So how does this replace everything that we have? Well, let's look at what it serves or what it provides. On the networking side, cloud optimization. So what does that mean? That means that if we go down in any of these locations here, we can switch over to different POPs. They call them POPs or point of presence. Cato actually has 60 different POPs across the nation. So if this user is accessing this POP here in Albuquerque and it goes down, it automatically uses its backbone to connect to the next nearest POP. So that gives us the redundancy that we were talking about. Now we can keep this person online no matter what, in a similar fashion that we did with our traditional network and redundancy. WAN optimization, what this means is that we can modify how much bandwidth we give to different types of data. Our video and phone data, we want to give more bandwidth to. We want those calls to be clear, the videos to be seamless, and the rest of the data can be checked as it comes through and reassembled the way it does in a traditional network. We've got the global route optimization, which is what I talked about in the POP scenario, and dynamic carrier selection. So through this, Cato has a virtual private backbone, and at every POP location, it selects, Cato has selected the two top ISPs in that region for redundancy. So now not only do we have redundancy in the point of presence, but for example, in Albuquerque, we've got CenturyLink and we've got Comcast. Well, if this global private backbone, this big circle here that goes horizontally, if this is served currently by Comcast and Comcast has an outage, it automatically switches over to CenturyLink to continue things going. Again, built-in redundancy, and that's what we want. Security, so firewall as a service. Well, what does that mean? Well, it says as a service, and that's exactly what it is. We no longer need an actual firewall box to do the rules and to vet the information that's coming through. It all happens in the cloud. Not only does it happen in the cloud, it happens at multiple points. So first, when the data leaves, it gets checked by our point of presence. Once it starts to travel through Cato's backbone, it gets checked again to make sure that the information that left from this machine matches what it was when it reached this POP, and nothing has been introduced. No viruses, no malware, things like that. And as it continues to traverse through the network to get to this endpoint, it is once again checked as it comes in to the next location. So it does all of the security compute in the cloud. It doesn't have to come through any of our devices to check that information. You know, the big advantage of that is that we've now eliminated two very expensive machines to do this intrusion detection and this firewall checking. It all happens in the cloud as the data travels through, just like it did with MPLS, but we didn't have the redundancy and we had all the extra equipment. So secure web gateway, again, it checks all the information that's coming in from the internet. Intrusion protection and next generation anti-malware. So we get some antivirus checking and cloud access security broker. So this happens when we are working with other services like AWS or Azure for our other integrated cloud services. So that's infrastructure as a service, and that's something totally different. So in a nutshell, we get everything that we need using SASE. A SASE that's not just it's not just any kind of SASE. So Cato is one of those top category SASE services that provides a fully cloud native, converged global network system that's already ready and up and ready to go. So we've got this high availability, scalability, elastic scalability, excuse me, and we can work from anywhere with a simple client install. So we can already kind of see how this just really reduces our footprint. And all of this happens with these little Cato sockets. So instead of having routers, firewalls, intrusion detection systems, all we need to do is route our data through these sockets. It then goes out to Cato's private background, and all the magic happens in the cloud. So no more expensive security closets are needed. The energy costs, the equipment costs, the salary costs, all of that goes away with this infrastructure. So let me just kind of show you what the cost is. I have reached out to Cato and received a quote from them. And this is what we're looking at for the next 5 years. We had a $3 million budget. We saw that our traditional path was going to cost us about $2.5 million. We could probably shave off a couple $100,000. You would be happy with that. But look at the footprint and the savings that we get with SASE technology. You can see that the switches don't go away. We still have physical equipment in each location that we need to connect to. So we'll always have the switches, the data comes through, we'll patch that off to our physical hardware in the building. Of course, with Wi-Fi, there's other savings there, but we'll talk about that later, perhaps in another presentation. But we still need the switches and we still need redundancy. So that cost doesn't go away. The cost that really, where we really see the savings is we've now cut out firewalls, intrusion detections, devices, the MPLS service is gone, and we've replaced that with a socket, the Cato socket that connects us out to that virtual private backbone where all of the security and the routing and all the networking happens now. We don't need all of that stuff because it happens there. So the cost of a socket is $1,500 per location. So we're going to need 8 of those. So the cost doesn't go up unless there's some type of change in the technology, which at this point it's so new that we don't know what to expect. So for the next 5 years, though, we can anticipate that this is going to stay the same. So $1,500 times 8, $12,000 for the next 5 years. Compared to, and if we just go back a couple slides here, routers, switches, and firewalls, look at this cost. Huge. It's astronomical. And the intrusion prevention. We come back, we take a look at that. That all gets replaced by the SASE socket that then takes it out to the cloud native infrastructure, does all the packet inspection, does all the security, does all the networking. The SASE service itself, $28,000 a year. That's for all locations. Remember, we're now through a single pane of glass, so we don't need to take a subscription for each location. This single pane of glass gives us overview of our entire network. So it's one yearly cost, not 4. So we've got 28,000 quantity needed. I took 5 here, and $140,000 is what we're looking at. Salaries, $400,000, because now we only need 1 engineer to do this. I did again base this on an average salary. Maybe we can pay the network engineer a little bit more. At any cost, or at any rate, this is the total cost for 5 years, $732,000 for the SASE network. That brings us to a savings, $1,816,000 over a 5-year period. So obviously, tons of money coming back into the company for other things. We can build new infrastructure, we can bring on more talent, or we can make our investors very happy. So in a nutshell, I just wanted to introduce this. I can bring together a proof of concept for you. We can set these up at a couple of our locations, show you how it works, get our proof going, and we can make a decision from there. But I'm feeling confident in this new technology. We've vetted it out through our partners, and we are ready to move into this new realm of infrastructure. So with nothing further, that's my presentation. That's my recommendation, is that we actually do go to the SASE infrastructure. It's going to prepare us for the years coming, and the sky's the limit from here. Technology is only going to get better, and we're only going to be able to do more with it. And it makes sense for us to jump into it now. It's available, it's solid, and we are ready to move on it. That is my presentation for you today. So what I'll go ahead and do is we'll go ahead and go to questions. Anybody has any questions, please feel free to send me an email or go ahead and post in this forum here, and I'll go ahead and I'll make sure to get back to you. But that is my presentation for today. I'd like to thank you for your time and wish you a wonderful day. Thank you, everybody.